Yeah. So you can remember it like this. If it is positive, then it will point upwards.
Okay.
Negative, it will point downwards. That is the first basic thing we already know. So I want you to review this graphs. If A is equal to 1, it will be like this, right?
Mhm.
And if A is negative 1, it will be symmetrical mirror for A is negative 1. And when does it shrink upwards? Which region? When does it shrink?
When it's like greater than 1.
Is it greater than 1?
Oh, when it shrinks?
So basically A is greater than 1.
Yeah.
And if I draw a mirror image of the blue one, this will be,
A is greater than negative 1.
the thing is,
Oh, A is less than.
yeah, A is less than negative 1. See what happens when you, for this inequality, when you multiply negative 1,
It reflects onto this one.
this will become less than, right?
Yeah.
This inequality is if you multiply negative 1 on both sides. So when you multiply with negative 1, so negative A is less than negative 1.
Yeah.
That is how you can remember. Negative A means A is negative and A should be less than negative 1. Like that you can remember.
Okay.
Fine. Similarly, this also applies to the other one. When does it stretches,
When it stretches,
gets wide,
less than 1, but greater than 0.
A is less than 1, but also in this region A is positive, right?
Uh-huh.
So we add greater than this. So mirror image of that will be,
A is less than 0, but also less than negative 1. Or,
say, simple. You look at this above, multiply with negative 1 on all sides.
so 0 is less than negative A, which is less than negative 1.
Okay, when you multiply with negative signs, what happens to this sign?
It flips.
Flips, right? So it becomes diagonal,
Okay.
like this. You understand this?
Yeah.
This is easy, right?
Yeah.
See, 0 greater than negative A means what? It's like A is less than 0.
Yeah.
So this new A is less than 0, is greater than negative 1. Or if you want to write it reverse, negative 1, A and 0, like this. These both are same things.
Okay.
So you understand the concept, right? You multiply with negative 1 for this inequality or this inequality. You multiply with negative 1 to get the mirror image.
Yeah.
So I hope it is clear. This diagram is important to remember, fine?
Uh-huh.
Because that was the first question, right?
Uh-huh.
So let's go to the next point. Completing the square method. Is it taught? So completing the square method, I'll tell you a trick. This will be useful for algebra in general. Let's say I have an expression, quadratic expression, x squared plus 7x plus 9, let's say. This expression, completing the square means you are writing in terms of some perfect square plus some constant value there.
Uh-huh.
I'll tell you a trick. How to fill this brackets. First things first, you drop it x as it is.
Okay.
When you drop positive sign or negative sign, whatever is there as it is, this term will be half of this.
Okay.
X plus 7 by 2 whole square
Okay. Plus 9.
plus 9. And then what you need to do is you subtract with 7 by 2 whole square.
Okay.
This is a trick.
Yeah. Is there a way to keep it just as this? Like with none of this?
Well, the thing is 9 minus 7 by 2 square. You can subtract them. This simplify this.
Okay.
So basically 9 minus 7 by 2 whole square is what? 7 square upon.
2 squared.
So basically 9 minus 49 upon.
4.
So therefore 36 minus.
How'd you get 36?
Subtract these fractions.
Oh, okay.
Bring 4 like this. 9 fours are.
36.
Do you understand this?
Yeah.
We can use calculator also. That is not an issue.
Yeah.
Ace will be equal to.
3. 3.
It's not 3.
Yeah.
So this entire thing was negative 13 upon.
4.
Negative 13 upon 4. Just a bit careful with the sign. So this becomes x plus 7 by 2 whole square minus like this. What is the a value? This is a quadratic.
X.
A value.
A value.
Is this in the vertex form?
No.
It is.
It is?
See, vertex plus square method.
A is 1.
H is?
7 over 2.
Is it 7 over 2?
Yeah. Squared.
Say. Tell me the formula for vertex form.
Y equals ax plus h squared minus k.
X minus H.
Oh, okay. Uh-huh.
So A value is 1.
So x is -1. -7 over 2. I don't know. I said 1.
K is?
K is -13 over 4.
13 over 4 or negative 13 over 4?
Negative.
Negative, right?
Uh-huh.
So this is the vertex form. Fine.
Okay.
If you want to draw this graph, you know the vertex coordinates, right?
Uh-huh.
Let's say vertex coordinates are, negative 7 by 2 comma.
13, -13 by 4.
And graph is upward or downward?
Graph is upward.
Upward. So it will be opening upward, right?
Uh-huh.
So it will be like this. This is the graph. So it will be in fourth quadrant, third quadrant actually. This is y-axis, this is x-axis.
Uh-huh.
X is in the third quadrant and it will be opening upward. Axis of symmetry is something like this. Equation of this line is?
It's -7 over 2.
X is equal to negative 7 over 2.
Oh, yeah. Okay.
AOS, I'm ready. You know what that is?
No.
Axis of symmetry.
Okay.
Axis of symmetry for H, right? H is equal to, formula for H will be NSB by
2a.
formula for H value. So if ax square plus bx plus c is given, the x coordinate of vertex dx is equal to h is equal to, in this, the ABC values, negative b by 2a.
Okay. Can you cover a little bit on how to shift, like change from standard to vertex and from vertex to standard?
Yeah, we'll cover that. It is this in the next part. Third point is maximum minimum. Maximum exists for if the graph is downward. Like this will be the maximum value. It exists for graph downward. Minimum value means this is the smallest value, right?
Also,
So it exists for
when the graph is upward.
one upward parabola. So both, notice one thing, both maximum and minimum.
Uh-huh. It's the vertex.
Yeah, good job. Vertex. That means x coordinate of vertex. Formula still applies.
Okay.
Still is still applicable. Fine.
Uh-huh.
Axis of symmetry equation line is line equation.
X, x is equal to whatever 8.
H or whatever it is. Fine.
Uh-huh.
So this is about maximum minimum. So for maximum, if the maximum value is y, if the maximum value is vertex h comma k, y value, right, is a k.
Okay.
So minimum
Wait, y value
h comma,
also okay?
yeah, both are vertex, both are verbs. Values are maximum and minimum values are k.
Mm-hmm.
So maximum, minimum, both are vertex and their values are equal to k. And x coordinate of the vertex is this. Axis of symmetry line equation is this. So let's move on. I'm writing this all at one place so that it will be easy for you to revise. No need to skim through 3 or 4 pages.
Okay.
So this single page is like enough. Very okay. So converting one form to other form. So basically, there are 3 forms for function, quadratic function. Just like how we have 3 forms in lines. One is, can you guess the first one?
Standard.
Yeah. Second one,
Vertex.
a vertex,
And factored.
factor.
But the thing is, factored form is not going to be on the test because that's topic 8.
Yeah.
But that's
Remember that for me, fine?
Uh-huh.
So let's understand these 2 things. Standard form is when the formula is y is
So y is equal to ax squared plus bx plus c.
vertex form formula quick.
A times x minus x squared plus k.
Here. So that is the first point. Second point is, okay, h comma k is called
The vertex.
vertex. H value can be found as
which is equal to x is negative b over 2a.
this same ABC. What B and what A? It's like standard form A and B values.
Okay.
And can you tell me y-intercept for standard form?
C.
C. So for y-intercept, put what as 0?
X as 0.
Yeah, for y-intercept, put x as 0. For x-intercept, put y as 0.
Upper.
So y becomes?
Y become C.
Yeah, 0, 0, C is remaining. So 0, comma C is y-intercept.
Yeah.
Now that you understood y-intercept, let's talk about x-intercept. What do you understand by x-intercept?
Where the graph touches X.
X-axis, right?
Yeah.
That means it is nothing but
Versus
general formula we know. For x-intercept, we put what as 0?
Y as 0.
We already know that y is equal to x square plus bx plus c. If you put y as 0, this becomes ax square plus bx plus c without the zip.
Uh-huh.
That is the thing.
Okay.
So roots are x is equal to formula, you know,
No.
minus b, this one. Is it not?
No.
Okay, fine. If you solve for x using factored form or whatever, solve for x to get what intercept?
X intercept.
That is the concept. Fine.
Uh-huh.
So this is about forms. The next point is how to convert, how to move, how to transform one form into the other form.
Okay.
So vertex to general or general to vertex. These are the two forms, right?
Yeah.
We are discussing about for this publish. So how to go from vertex to general and how to go from general to vertex. Vertex form is something like this, right? You already know this.
Yeah.
So first we discuss about vertex to general. So this is a vertex form. How can we move on to the general form?
Okay, well, let's see. Can I try to do it? The first step is y is equal to ax squared. So you input a and x. You input the numbers for a and x, and you square them, right?
Okay, let's say we deal with numbers. Convert this vertex form into general form.
Okay. Y is equal to 2x squared. Well, how do we find b?
Well, I'll tell you one trick. I'll tell you two tricks. First thing, h is equal to h should be equal to,
Negative b over 2a.
do we know h?
A. Yeah.
How much?
Negative 1. Or positive 1.
Yeah, positive 1, right?
Uh-huh.
Should be equal to
Negative b by 2a.
a is
A is 2.
twice a. B is
Uh wait, 4. No, negative 4.
negative 4. What about c? What is c actually?
C 1.
C, k is 1.
Okay.
K is equal to 1, not c. C is called, we gave it a name.
The constant. Y-intercept. Oh right, yeah.
C is equal to y-intercept. So for y-intercept, you put what at 0?
X at 0.
So y-intercept, so put x is equal to 0. This x value, what happens? Can you calculate?
It's equal to positive 1. Is it still equal? Oh, I'm not sure.
Put x equal to 0 here. Plug in x value. The original equation,
Uh-huh.
put x is equal to 0. What is the y coordinate?
Okay, so 0 minus 1 is negative 1 squared is positive the positive 1
Positive.
1
Positive 1 times
2 is 2 plus 1 so is it
2 plus 1
yeah
is
3
3 or 1.
2 plus 1 is 3
3, right?
yeah
The c value is 3. 1.
okay
So y value will have. A was 2, b was negative 4, c was this.
uh,
Now can you write the standard form? Tell me orally what is the general form now? Y is equal to
y is equal to 2 squared wait no a a x squared plus minus 4x plus 3
this is the mindset. And this is what form?
standard.
So did we get vertex to standard form?
Yeah.
Now let's discuss about standard to
vertex 4.
standard form or general form. It is the same thing. And
Mm-hmm.
standard to what form?
Vertex.
So let's say y is equal to.
Y is equal to ax squared plus bx plus c.
So from here we have to line the brackets.
Mm-hmm.
So let us consider this example. 2x squared minus 4x plus 3. And
Uh-huh.
how do we get vertex form?
Well, vertex form is y is equal to ax minus x squared plus k.
This was you already know.
Okay, k. It's 3.
See, k is not equal to c. And
Okay.
k and c have different things.
K is equal to y.
First, I get this. What is this?
Oh, a. 2.
So this will be
A.
okay. How can you obtain h and k not?
Negative b over 2a.
Good. What is b here?
That's a so 4 over 2 times 2, which is 4. Which is 1.
H value is 1.
Uh-huh.
Now we got a value. We also got h value. Now, what is left?
K.
K, right?
Uh-huh.
How do we get k now?
K is equal to y.
To find k value, only y-intercept constant.
Okay.
We know that 0 comma c is the y-intercept.
Uh-huh.
0 comma c, right?
Yeah.
So that means x is 0, then y will be c. C in this case was?
Same 3.
C is, 3. So if you put x is equal to 0, you got y is equal to
Y is equal to 3.
3. Y-intercept, right?
Yeah.
So C value. So why don't you use the concept in here? So let me just modify that. You know already h and a value. A value is this, x value is 1 plus k, right?
Uh-huh.
And 0 comma 3 is a point.
Mm-hmm.
Can you get now a k value? 0 comma 3 point satisfies this function.
Uh-huh.
So where do you need to put 0 and where do you need to put
0 to x.
0 comma 3 is coordinate.
Y.
So
Wait, do we put 0 in x and 3 to y?
you put x as 0, y value will be.
3.
So here you need to write
3.
d is equal to
2 times 0 minus 1 squared plus k.
how much now?
Let's see. 2 times 0 minus 1 second 1 squared is 1, 2, 0.
1 0.
Wait. Oh no, 1. I meant 1.
So 3 minus 2, right?
Okay.
So k is equal to that is the thing. So if you put here this one also, the form becomes h minus 1 whole square plus
1.
this is the vertex form. So standard to vertex and vertex to standard.
Uh-huh.
So that's the concept. And then we'll talk about the only one type of the cities domain, which is called domain and range. And
Yeah. Usually now.
okay, we finish this quick and we can go back having a breakfast. And
No, it's okay. X values,
range means
Y values.
y value. So depending on the case, the graph will be either upward or downward, right? So let's talk about them separately. Domain for a quadratic function is always real numbers. Fine. R.
Uh-huh.
This is important point. Doesn't matter if it is upward or doesn't matter if it is down.
Okay.
Yeah. Domain. Possible values of x is real numbers. This is only valid for quadratic functions, okay? Then quadratic functions is fine. So cubic functions it is also valid. So for now we are focusing on quadratic functions, right? Try to remember this point, okay? So domain for a quadratic function, real numbers. So doesn't matter this or this. Boom. Real numbers.
Oh, real number. Yeah. Okay.
I hope this is clear. So domain concept is clear. Now let's talk about range. Range is so simple. For this type of graph, do we have minimum or maximum?
Minimum.
Minimum. Minimum value means, okay, range, right? Range with 5 values. Minimum means you use greater than equal to or less than equal to. Which one?
Greater than or equal to.
Yeah. Minimum means greater than or equal to this
Uh,
h comma k, right?
Yeah.
So y is greater than or equal to?
Okay.
Good. K, right? Can you tell me the range for this? Y?
Is less than or equal to k?
That is the concept. So maximum value is k.
Oh, that's so easy. Okay.
If you understand this, concepts will be easy. Fine. So domain for a quadratic function, unless it is specified, is always real numbers. So it's like if you restrict the quadratic function up to here only, if you want to consider up to this only,
Uh-huh.
we know that it will be like this, right? It will be stretching.
Yeah.
But if the question has the quadratic graph up to here only this portion, if the question is considering only this portion, the domain will be from here to. So unless and until it is specified, you assume the domain is real numbers. In this case, let's say this is x is equal to L and this is B. Domain will be
Okay, wait. X is greater than A.
less than is equal to B.
Yeah.
So from A to B. Or you can write it like this. Square brackets. I think you wrote this.
Yeah.
Yeah.
Wait. How do we know if they like specify it? Because sometimes it's hard to tell if they cut it off or if it's like that's where they want it to end.
See, the thing is, if it is drawn automatically in the question, if it is given in the question, they will specify it.
Okay.
They will draw up to here only. If you look back onto the questions, onto those 13 questions, there are some questions in which the graph is like this only. So it is easy to navigate, right?
Yeah.
So you review them, you'll understand what that means. And range can be, can you guess?
Range can be less than or equal to k, greater than or equal to 0.
0. X-axis means 0.
Yeah.
X-axis means line equation is y equal to 0.
Okay.
Y greater than or equal to 0, less than or equal to k. And
Uh-huh. Yeah.
h comma k intervals. That is the concept. So review these things. I've written all the concepts today, yeah?
The writing, the solutions.
Yeah. Simple final differences. How do
What?
that
Find what?
differences? First difference, second difference.
Oh, yeah. Okay. I need a list of numbers.
But it's zero, right?
Yeah, I know. And I know if the first differences are the same, it's linear. And if the second differences are the same, that's
So
quadratic.
if you get the numerical values are same, the first difference, same numerical values, the graph is, the function is
Um, Linear.
linear. And how do you know if it is a quadratic?
If it's a quadratic,
For quadratic,
the second differences are the same.
second difference means difference of first difference values.
Yeah.
So difference of first difference. This concept makes sense, no? So first difference numerical values. That value is difference. Second difference.
Awful.
And if second different values are equal, second different values are equal, the
It's a quadratic function.
quadratic. If they are not equal,
Uh, I don't know.
then it is simple. It is not a quadratic.
Okay.
So not a quadratic. And if you want to know if it is an exponential function, what is the process?
By Meritrian,
Ratios. So if equal ratios,
then it's exponential. Well,
I think up here it is done. Okay.
okay.
Because sometimes let us try to go a bit deeper. By your way, says difference or second difference or exponential tests. So finite differences. These are called finite differences. For finite was ensure that are arranged in sequence or
Yeah.
sequence wins with them. So generally, only question for this topic will be like fundamental decide Turner values.
Oh, yeah.
Like this, right? The value should be increasing matters. So 0.5, 1, 1.5, 2, like this.
Okay.
So this is all. Bus. The city that he asked, the order is jumbo. Then Tixu was up. It was like first it starts with 0.5. Next it starts at 1.5. One below This is not in order.
Yeah.
So if it is in order, then we
You gotta rearrange it.
rearrange it.
Okay.
So I hope it is clear. So generally, any version, just make sure that x values are in order, not the y values, but the x values. X values, arrange them in what the
Okay. It doesn't matter with the y values though.
yeah, it doesn't matter. We have to look out for x values only, not the y values. We don't care about.
Okay.
It's not about the. It's not about the y values. About x.
Okay.
So from that.
Yeah.
So that's it for today's class. I think we covered almost everything. Anything is left?
Go.
Go. So now you understand the homework, right? Try to write those answers and send me the pictures, right?